All right, number 12. We have this triangle, and we're asked to find this distance, the length between B and C. So the length of this side, which we're not going to call BC, we're going to call A, since it's across from angle A. Let's just call this side little a. And that's what we're trying to solve for here. Now we can use the law of sines, because we've got two angles, so we know we can use the law of sines. Anytime we've got two angles, or if we've got two sides and an angle that's not in between those two sides, we can use the law of sines. But in order to use the law of sines, we're going to need to know this angle. Since it's across from the one side that we do know, we're going to need to know angle B. And to find that, we're first going to add these two angles together and subtract from 180, because all three angles in a triangle have to add up to 180 degrees. So 65 plus 24 is 89. 180 minus 89 is 91 degrees. So angle B is 91 degrees. And now the law of sines says that the sine of angle A, 65 degrees, divided by the length of side A, which we don't know yet, is equal to the sine of angle B, so the sine of 91 degrees, divided by the length of side B, which is 32 centimeters. All right, and now in order to solve for A, we're going to need to get rid of both of these fractions. We want to get A by itself. So we're going to need to multiply both sides by A. And we're also going to need to multiply both sides by 32 in order to get rid of both of these fractions. And the shortcut that we usually use for that is cross multiplication. So A times the sine of 91 degrees is equal to 32 times the sine of 65 degrees. And then to get A by itself, we'll divide by the sine of 91 degrees on both sides. And so we get A is equal to all of that, 32 times the sine of 65 degrees divided by the sine of 91 degrees. We plug that into our calculator and we get that A is equal to 29 degrees. And that's rounded to the nearest tenth. It's actually 29.00. So rounded to the nearest tenth is just 29.0. And that's our value for A, which is what we're looking for.